slide deck is not loading.
Okay.
I don't know what that is.
It's I'll talk about it. It's not mission critical.
Okay.
All right. So it looks like we're recording, and I'm really excited. It looks like we got a lot of folks here this morning. Thank you, everyone, for joining us. And this is the third annual METS Group Virtual Rally. We started doing this to kind of find a way to get our different folks together without having to go through the threat of driving through snow and winter. So last year, when we organized this, we actually had a snow day almost statewide. And so the virtual rally was pretty important, having that opportunity to connect this way. There's a little bit of snow today, but it's nice to not have to jump in the car and try to get somewhere, even though being face-to-face is really, really nice as well. So Andrew, go ahead and flip to the third slide. We do have a hashtag. It was on the second slide that if you want to use this today, if you're on Twitter and you want to share out something that was going on, we use the hashtag MishEd and then the minus sign or the hyphen with METS connected to it. So if you use that hashtag MishEd-METS, that will allow you to share resources via Twitter. The other thing that I'd like to share is that this year we did create a website for the METS group, and that is metsgroup.org. So I'm going to ask somebody to throw that into the chat for me, just so that there's that link. So we've got a nice website that's there as kind of a placeholder for all of the resources. And then, of course, the Google Plus community is a place where we can gather virtually and share resources as well. This group, you know, there's almost 500 different folks around the state now who have signed up to be part of the METS group, but there are a few of us who have kind of been volunteering throughout the year to put on these various events and to help kind of keep the momentum going. And so the faces that you're seeing on your screen make up the steering group committee. And I have to really thank all of these people, because without them, there really just wouldn't be much happening. And they're a great dynamic group and really committed to connecting all of us and allowing us all to share resources and grow as a group of ed tech leaders in the state. Go ahead and go to the next slide there, Andrew. So just really quickly, want to talk a little bit about who the METS group is. That's ed tech specialists that sort of started, people working at the district and regional levels who really wanted to find a way to get connected, but it also includes classroom teachers and district administrators. It's a very diverse group, but anyone who's really kind of looking to connect around what good educational technology looks like. And so we've been sharing along the way for the last couple of years. If you want to go to the next slide for me, Andrew. So we have several different opportunities throughout the year to collaborate and support each other. We do some face-to-face events. We have a fall rally that we do, and we also do this winter rally. We have the virtual connection through the Google Plus network. And then we're also going to be doing a spring event, which I'll talk about here in just a few minutes. Go ahead and go to the next slide there for me, Andrew. So each year we've kind of set out some different goals of what we want to try to do, and connecting people is one of those. We also did a Bring a Buddy scholarship this year where ed tech leaders could register or apply for a small scholarship to take someone from their district with them to a state PD event. And so that's something new that we've done. And now we've also got our newsletter this year and some things like that that are kind of new events. So just kind of keeping you in the loop about those things. Go ahead and go to the next slide. One thing we're really excited about this spring, we are bringing back something that happened 2 years ago called the Idea Slam. The Idea Slam is a pitch event where you can put forth sort of your brainchild idea and not only get support from this community, but also have some financial resources. So this link that's here, the bit.ly METS Slam, will take you to a resource that would allow you to, if you want to put forth a pitch, we're looking for ideas that will really kind of have a far-reaching impact, something that will inspire others in the state around education technology. And 4 of those applicants will be picked to pitch their idea to this group and to educators who are going to be in Detroit during McCall Week, and it'll be the Wednesday night. It's going to be at a really cool venue in downtown Detroit, the Elizabeth Theater and Park Bar, and it's just going to be an amazing event. So we really hope that you'll attend. It's going to be the thing to do on Wednesday night, the 15th, and we also hope that you'll consider putting forth a presentation or a pitch and kind of make this a new tradition for the METS group and for that McCall Week. Go ahead and go to the next slide. Also at McCall, we were invited, the METS group, to host a small meetup on Thursday in the vendor hall at the McCall Zone. So several different state organizations are going to have events in the McCall Zone, and we're going to be there from 3 to 3:30 and have just an opportunity to shake hands, talk a little bit about the METS group, and maybe look at what do we do in the next coming year as a group. So go ahead and go to the next one for me. And then also in the newsletter, we had a book giveaway this month, and the winner is Jillian Johnson, and she's getting a copy of Hands-Free Mama. So we're always trying to find different ways to engage with all of you and to make this a dynamic group. So little giveaways and things like that are one way that we can say thank you for all that you contribute, because without this membership and all of the ideas and being here today, it wouldn't be nearly the group that it can be. So thanks. So here's how it'll work today. We have our keynote, which we're about to start in just a couple minutes here. And the different links that you see in this agenda document will bring you into the various rooms during the breakout sessions. We'll have 3 breakout sessions for each hour block. You can click into the link to room link at the top to enter the room. And then the presenters will have different resources for you. You can see at the bottom of each of those blocks, there's generally going to be a link to the resource sessions that you can use. And that will be the interactive part. We're going to really encourage you to do more than just sit and get today. Your facilitator of those sessions is going to ask you to engage around the topic or idea. And so please consider doing that. And then we've got some giveaways, 3 $10 Amazon gift cards per session that different participants will be eligible to win. So stick with us and win a gift card. All right, I think we are ready now. Andrew, I'm going to let you take over. And everyone, please enjoy the keynote.
Hey, everybody. I'm Andrew Steinman, EdTech consultant at KenISD. I'm not going to speak for very long. I'm just here to introduce our keynote speakers, Ebiri, Nkugba, and Rick Mushing. And they come to us with extensive experience both in industry and education. And so they have some great information to share with us regarding STEM. So I'm going to let them take it away.
Okay. And we are making just a couple of clicks here, folks. Hang on one second. Right.
We're good.
So there that goes.
So you want to, I got it.
Got it.
Oops.
Oh, we're up. We're going? Good. Perfect. Thanks, Andrew. Good morning, everybody. Thanks for having Rick and myself into Keynote for the METS group. We're going to talk about connecting with industry today. And go ahead, Rick.
I threw this slide up there, and I wanted to talk to you just a bit about technology, but it was kind of a preaching to the choir type of thing. I didn't want to spend a lot of time on that because you all live in this world and you know what's going on. Things are moving really rapidly. Everybody we talk to in industry, the projections they were making for 15, 20 years out, those projections are now happening in 5 to 7 years. And by that, those projections, I mean the rate of software development, the rate of new technology they're releasing. Things are rapidly accelerating. With what we do, we work a lot with those industries, and that means to make those connections, we have to stay at pace with them and understand what they're doing to allow our teachers and our students to also get that information. So I thought it was kind of interesting that top about the grains of rice. That was 2009, and we're producing more transistors than we eat, 250 times more transistors than we eat grains of rice. That's just a lot of electronics. That just shows where the industry is heading, and that was 2009. It's been exponential since then. I couldn't find any current numbers, but it has grown significantly. And then I grabbed some funny
That's
images.
an engineering joke, that next piece there, the guy that's the bird that's standing on the wire. Sometimes those go over like lead balloons for us.
They usually do.
Okay. So Rick and I work in the Career Readiness Department. We're STEM, Science, Technology, Engineering, Math consultants. We're part of a larger group in Career Readiness. There's 3 career exploration coordinators. We'll talk a bit about them, and then our career readiness consultant, and we'll just share quickly some of the work that they do. So this slide here, we're just talking about kind of some of the major groups, and then on the far right side, you can see some of Rick's and my specific work. On the left side, because we're talking about connecting our classrooms to industry, that's what our whole department is wrapped around. So at the top there, we have something called Teachers in Industry, where we take our educators to, in West Michigan, we are absolutely full of manufacturers, construction companies, software firms now are really coming up. We got this medical mile, so there's a lot of industries that work with education. So we take the educators out. We also bring a number of guest speakers, so those professionals will come into the classroom and explain, hey, yeah, I use that biology. In fact, we're going to show you a lesson here in a bit. I use that biology in my day job. That's what you're learning in class today is what I do. And then Eric is our career readiness consultant. He works around some of those soft skills. So how do you interview? How do you become flexible and adaptable to either a changing work environment or changing job roles, those kinds of things, webinars, PDs, stuff like that. You want to talk a bit about the other?
Yeah, but I did want to mention, so as we talk about this in industries where we see your group fitting in, we're coming back to teachers and schools and the districts overall and saying this is what we're seeing in industry. And industry has gotten pretty demanding about what they think education should be doing, and they want us to introduce more technology, and we think that's the perfect gap for your group to fill. As we go out to teachers, often teachers are pretty apprehensive to pick up this new technology, and we think your group can help fill that gap and get them through and get them to using this new technology, or some of the newer technology we're going to see.
Yeah, we can move on from there. So as we've approached some of that, this was some of our data from last year, so we just wanted to show you guys. We do a review like this every year. About 12,000 students were impacted by our group last year, and we're getting really, really good feedback from the classroom teachers, from the students. We could tell you many, many anecdotal stories, but just wanted to put this graphic up that we produced on our team. And I want to draw your attention down there, kind of left middle. It says 89%. The employer side of this equation is really very, very excited to be working with education, and they're saying, hey, this did a great, they're looking for employees, right? They're looking for new folks to come into some of their fields. In nearly every case, they're hurting for talent out there. And it really is your type of content, the integration of technology, how to use the technology, how do I solve this business problem using that tool to get things done. And they are very excited to have students all the way from kindergarten up through, 16, 20 post-secondary work in their businesses.
And typically when we go out and talk to employers and ask them to participate in these events, they're eager to get on board. And a very common response, the employer will say, yeah, we wanted to tie to education. We had no idea how to do it. Nobody contacted us. They didn't know who to contact. So just finding those employers, making the contact, telling them what you want to do, it's been a pretty easy sell with employees. And the big message on this slide is how much this has grown, indicating how much demand there is for this. And the second message here is the students and teachers are also seeing great value in those connections.
So we talked a bit about kind of general career readiness. We want to zoom in just a little bit tighter on Rick's and my work specifically. So when we define STEM, we look at STEM as obviously the integration of those 4 topics, science, technology, engineering, and math, but then it's used to solve some type of real world or adult world of work problem. We put a question mark there for graphic. There's lots of graphics that demonstrate kind of the talent pipeline and some of what Rick was talking about, how this technology has accelerated. We have too many of them, we couldn't decide which one. So they're struggling to fill these roles. That's why they're so excited to have educators work with them and bring the students in early. So here we've got a video, and I want to, if I could get just a thumbs up from somebody when I start playing this. I got Andrew left the room, but we should be able to toggle to a different tab here and listen to this. So this, just quick preface, this is Mr. Hayden Land. He is Vice President of Civil Engineering Systems at Lockheed Martin. Forgive the quality, it was a Skype call. So this was a Skype call. I Skyped him in here to Kent ISD. He spoke to our Kent Learning Collaborative, which is most of our curriculum directors and administration around the county. And so this is what a business leader means when he's talking about STEM and STEM education. I'll play this.
No, so we've got no speakers, we can't hear that.
And SIP and declining overall regarding the evolving careers. So you can hear, just as Mr. Land talks about it, that's really what the business sector is looking for. They're looking not just for kind of that, what I think a lot of folks would say is STEM, kind of that engineering side of things, but also for us, the art side, kind of the, what would I say, the creative. He describes it as a divergent thought set, right? So if you're able to take an idea and expand it. For us, that's embedded within the engineering. And I used to tell my electronics students, I'm like, look, nobody's going to buy that from you if it looks, and I would say if it looks like a butt, if it looks stinky, if it doesn't have proportion, aesthetic, appeal, it's not going to sell. So you need to be able to kind of have that. Now, this originally was an animated slide, but it looks like it might have changed a bit when we uploaded it to Cisco WebEx here. So I'll just kind of talk you through what we're looking at here. So if you imagine, and this is kind of just positioning-wise how we're seeing kind of our educational tools and technology and support step a child through from kindergarten out through going on and being some type of, you know, successful adult human being, having a career, taking care of their family, that type of stuff. So if you can imagine in the middle, that middle circle is our standards, right? These are the things that we're teaching. And I just threw in, you know, high school physical science number 2 in there. And we got a lesson later, we're going to talk about that specifically. But then out from there, we as educators, we step those students through multiple different types of supports, and we use different tools to get that learning done. So we might be teaching you high school physical science 2, Maybe we're using a drone. Maybe we're using a 3D printer in Rick's case. Maybe we're using, you all work a lot with Google Drive. I've seen Andrew run a number of professional developments around those types of tools, smart boards, learning management systems. Then you see I underline career exploration because career exploration is really what, for a student, at least we emphasize it in career readiness, helps that kid launch from, okay, I learned this stuff, and now if I like, high school physical science standard number 2, if I really like that, what do I go and do with that? What do I turn myself into? And, maybe, historically you were an archaeologist or a business manager or a nurse. Well, Mr. Land was talking about some of those new careers that are developing, like a data scientist or a neuromorphic architect. We're going to talk some more here in a second about an Internet of Things developer, cyber forensic, and all of these different career pathways, right, that a student can become. And now, some of the work that I get to do now with drones, that was not a thing when I was in school. It wasn't, they had hobby, kind of toy planes that you could fly around, but drones for like civil engineering survey work and analysis of tree canopy, that was not something that happened. But I learned, a lot of that educational content area, and it allowed me to kind of look at that and start to get involved with it. So, as you step through from what are we teaching educationally and what are our standards out to, okay, what are we using to help teach that standard, try and think a little bit about, okay, and now where is this kid going in their life ultimately? At the end of education, now what are you, or what can you go and do? So that's what the big message is on this slide. I think this was you, sir.
So what we've been trying to do is break down pathways. We kind of have a vision of the end, what students might be doing in their careers in different career fields. This is one of those examples. When we talk about something like coding, one big thing for coding, and we've all seen how code.org uses a lot of animations and games to teach kids how to program, and those are engaging. That gets the students' attention. What we want to do is move the step beyond that, is get them to do some problem solving with coding, and we're definitely seeing some of that in the classrooms. We've got teachers that are saying, do this math problem, but create the code for it rather than just do the math problem. And we think that's a great way to go about teaching kids how to learn to code. And what we propose is a pathway like this all the way through a district where on the very left corner of this, Ebiri uses little bits. So he goes out to schools with little bits and just shows those students, gets them familiar with circuits, what circuits are, and get some of that logic thought process, get it ingrained with the students, or at least get the students familiar with that type of process. And then from there, moving on to something like an Arduino isn't such a large step. At the little bits level, we're able to teach the students, there's a power coming in, and then you've got input and output devices. This is how those input and output devices work together. So they start to build those logical connections. It's all we're trying to do with the younger grades. And then, of course, when we move up to Arduino or Raspberry Pi, those are significantly more complex, and now we get a little heavier in the coding, and that can be even confused further if they don't already understand the sensors, the input and output devices. And then maybe from there, moving to something more complex, a humanoid-like robot. We've got a lot of sensors all acting at once. And I talk to kids about all the degrees of freedom you're controlling at once, and the vision systems and the audio systems. And all of those tie directly to what's happening out in industry. That final picture there in the upper right, we've got large Fanuc robot controllers. And the KCTC, the Kent Career Tech Center here in Grand Rapids, they've got one of those Fanuc arms, and they teach that skill to students in 11th and 12th grade. So what we're trying to develop is really a pathway, almost a farm league type of thing, where students learn this at a real young age, where they're real eager to get into this type of activity and bring it all the way through and give them the opportunity all the way through their education to play with these different levels.
A couple of quick shameless plugs.
Yep.
Bottom left, the little bits, if you're anywhere out and around in our area, March 9, I have a professional development on those. Also, I would mention that we got a grant, we got a bunch of those things, so I'm going to train people to use them, and then they can take them out and use them in their classroom. Rick was able to get a grant for that actual humanoid NAO robot. We've got one of those. It's now in Thornapple Kellogg School District, right? And those Arduinos now are actually being used as some of the microcontrollers for those Fanuc-sized arms. Actual Arduino is being used for that. It used to be more PLC and programmable logic. Some of it is going to actual Arduino. So if you're programming that from 8th grade or wherever in there, that student really is learning something that if they like that, they can go on and have a job. Somebody will pay them to do that.
And that's fairly new in industry. In past years, industry has looked at those little controllers and wrote them off as kind of toys. They've gotten to a stability level and a usage level that they're I wouldn't say predominant in industry, but they're being used a lot more on newer projects. So the slide earlier we had, the different services we offer for teachers in classrooms to go out to a site or have a visitor come in, there's a lot of barriers to that. It's hard for a teacher to take a day off to do a field trip to a manufacturer site to see what's going on. The buses and everything else, the whole scheme to get that all rolling is kind of difficult. So in trying to make those connections still with industry, we try to figure out a way, or want to find a way, that we can make those connections with industry, get that information into the classroom without the students leaving. We played a little bit with live video. That was really difficult. There's a lot of challenges there, especially when you're on a factory floor. And what we came up with was a business problem video library. Ebiri and I go out and we interview industry professionals, and we ask them to state a problem. And they state that problem. We keep the videos under 2 minutes, a lot of times around 1 single minute. And the teacher might use that video as an introduction to a lesson, or they might use it as a content piece, or it might be the problem the students are going to solve in a lesson. So what we've got now is we've got a couple different examples of how we're using this business problem video library, some videos set up, and then how we use them in the classroom, just to maybe generate some ideas on your end and how you can use these videos. And these videos are available on YouTube. We have over 50 of them up there right now. We hope to have about 100 by the end of this year. So we've got a lot of videos on a lot of different topics from local industry professionals that we think can tie in very easily to curriculum and different lessons.
So this, there's multiple ways that these can be used. If you guys want to I know you can open different tabs and things on YouTube, but we're going to take you through a couple of these. The first one here, well, I'll just let it play. You'll get the idea. So let me pick this. So first of all, when Jonathan, I'm sitting there videotaping Jonathan for this, and when he started talking about blood cells lysing, I thought that was horrifying. I did not know that was a thing. Second, what an authentic problem. And I've worked with, there's an answer to that problem. So that video is a little bit longer than what we had mentioned, but he actually records their answer to that. So a couple ways you could use that. He specifically talks about in his answer, so you're a teacher, you're sitting there, you're looking at, okay, I got to teach the construction of blood, or the cardiopulmonary system, or I don't know, DNA. When he's discussing the DNA issue, he starts talking about some specific words that are mentioned in our standards. And I've had a number of biology teachers go, oh my gosh, this is fantastic. That is my lead into RNA DNA. So Rick did some work with this.
So I went out to a class in Lowell, went out to Lowell High School, actually worked with a 9th grade class, met with the teacher, showed her the video, and asked her, what standards do you think we can cover? Where will this fit into your curriculum? And she right away was able to identify a section she wanted to do, cell transformation, DNA. She's covering all that in her biology class. So it was really easy for her to say, yeah, I can definitely use it as an introduction. So she used it as an intro, and it was just setting up the fact that, all right, this is being used in industry. This is how this information is being used. And now we're going to study the components that person was just talking about. So I've got him up on the screen here. She identified the standards. Well, when we initially started out, there might have been more standards or maybe even fewer standards. But we went through a process of building this lesson plan around that video and what standards it might cover. So obviously that was a real important step in this. A teacher's job is to cover those standards, so she had to get through them. Now, a lot of text up there. I didn't mean to, I'm not going to read all these off, but as her and I worked to develop this lesson, what we wanted to do is come up with questions for the students that were lead-ins to projects, so problem or project-based learning, and these are just some of the examples, and she did not give the students just one question. I forget what her list was. It was at least 12 or 13 different questions that the students could choose what they wanted to do and how they wanted to use or research this information and what answers they were going to come up with for these questions. Now, when she did that, we also had a structure. We went through a design thinking process, or the students would go through a design thinking process. And in that structure, they had to do things like build a prototype to support their hypothesis to what the initial question was given to them. And through that process, the teacher was able to say, all right, we're covering this standard at this point. The students need to turn in this information. So she had different points throughout the design thinking process that she could assess their learning and also just make sure the students were on track, that they were learning those standards within this project. So we really had a structured approach to problem-based learning. So as we went through this, one of the things we used, one of the technologies we used was 3D printing. On the left is just a quick screenshot of Tinkercad. We use Tinkercad quite a bit in this project. And I love using Tinkercad out in the schools because there's no setup. You go out there and you can teach a 5th grader in 10 minutes how to use Tinkercad. But anyways, what their challenge here was to just take the different components in a cell and put them in the appropriate cell boundary. And then in different groups, they printed out, they physically 3D printed the cells. So this is replacing some of that rote learning rather than going through different slides or whatever or worksheets. They're doing something in 3D. They're manipulating things in 3D. And the burden of learning Tinkercad was so small that it did not interfere with them learning where those components go in the cell, which is often a big problem with technology. If the students need to spend too much time battling the technology, they don't learn what they're supposed to learn. This was real simple, and like I said, Tinkercad has been a great tool for things like this. After that, one of the standards we're going to cover was cell transformation. We printed out these, you can kind of see in the middle, they look like C's or circles there, the boundaries for cell walls. And she went through a lesson using those 3D printed cell walls. The students printed out those cell walls and then physically used them. And at this point, we're using them more as just manipulative devices. They're not really replicating anything than this is what the cells actually look like, and they're physically able to move them, obviously on a larger scale. So 3D printed parts, and they got to actually touch them and move them around, things you just can't do with a real cell. So the DNA portion then, the teacher was really creative here. We used Tinkercad again, and the spiral, the outside of the DNA I've got on the right, that was difficult for the students to do. A helical operation like that is difficult in Tinkercad. So I had to do that. I don't know if I use Inventor or SolidWorks, but I started the students with that base model. But then the teacher told them what DNA they had to build, what ladder rungs they had to put in between those two strands. And they then had to build that DNA model in 3D. So a little more interactive than just, again, filling out a worksheet, maybe drawing lines back and forth or coloring things in. They had to do in 3D. They had to spend a little more time positioning those components inside that DNA strand. So they they connected a little better with it, and it was a little deeper learning having them build that 3D cell.
By the way, that's Jonathan's job. That is literally what the man does, is he decomposes that DNA, figures out what's missing, what belongs in there, and he actually does, in some cases, build a three-dimensional model of a specific chunk of DNA and say, okay, here's what we need to do. We have that, we need this is missing, whatever. So you're having the student connect directly to. Sometimes we get this technology if it's a 3D printer or smart boards were a big deal there for a while, whatever it is, and then we're kind of struggling a little bit. Well, exactly how do we use this? So our big pitch is if you connect that to an industry problem, you're not only giving the student opportunity to contextualize the learning and go deep with understanding the specific content that's being taught, science, math, engineering, whatever, but you're also giving them kind of a lead in those earlier slides where they say, okay, what do I go and be when I'm an adult? That, Jonathan's job. There are people that do it.
And the student on the right, on the left there, little picture, I kept that picture because he kind of looked proud of his DNA that he created on the 3D printers. So I like that picture. And I've got a whole lot of those pictures.
Impressed with himself.
Yeah, he was. Yes, he was. So that was one example of how we use the videos. And like Ebiri mentioned, throughout that process, the teacher referred back to that video. And by the way, I coached the teacher at the beginning of that project, gave her information, and she ran with it. We try and stay real hands-off. And time-wise, too, we can't be there every day. And since we can't be there every day, it's real important that teacher feels comfortable enough with that information, and we give her enough information.
I noticed, too, in the chats a minute ago, someone had shared the link to where all of these are housed. You want me to pick this and play it? Okay.
So another video, Mr. Brian Rogney, he's an environmental engineer.
Go ahead and mute that, right?
So what Mr. Rogney is describing there is we've got a waste-to-energy plant here in Grand Rapids, Covanta. The DEQ came in and found a high level of heavy metals in the Grand River, and was coming out near the Covanta energy plant. So they assumed that plant was leaking somehow and leaking those heavy metals of that waste they collected to burn that was leaking those heavy metals out in the Grand River. That did not turn out to be the case. As Mr. Rogney's firm researched this, and some of you may have seen some videos on this, what was actually happening is those leaky garbage trucks that were pulling in to drop off the waste, they were leaking onto the pavement. Then when it rained, all of that sediment was washing down from the parking lot through the draining system into the river. And there's a great video I use called 15 Minutes to the River about all the pollution that sits on parking lots. When it rains, it all washes out into the river. Just another supplemental video we used in the classroom with this video. So we start out a lesson with that video. Mr. Rogney states, how would you solve this problem? There's heavy metals in the river, and that opens up a lot of different pathways. Obviously, the chemistry behind what is a heavy metal, how do you get out of water, all of those things. But first, for just a real simple approach, so if I'm working with an elementary school, we're just going to start with something simple like we're talking about the parking lot. How big is the parking lot? And then we just had them calculate the area. And then depending on what the class is doing, they might talk a little bit about what pollution is, what a heavy metal is, depending on what grade we're talking at, and how much science, chemistry that teacher feels comfortable with. But we're using one video, that same video for this elementary class, maybe just to talk about area at this point. But then using that same video in a middle school class, we're doing a lot more complex area. Now we've got curves and arcs, and the students understand how to calculate those areas. So I'm using math as an example here, but we could also be now ramping up with science. So now the students are actually putting heavy metals in the water and actually physically separating those out as part of an experiment. But again, as we go through this, we're tying to it what AECOM's statement was and what they actually do in their job process to eliminate these kind of problems. And then, of course, we go into high school, we ramp it up just yet another step. We came in with some engineering drawings. We actually had 3D models for the students, and now they're working with volumes, not just area. But the message here is each different grade level, we're just getting deeper and ramping it up appropriately to their level of standards with one video. So all these videos we've got up there, we intentionally did not put grade levels on any of the videos so that they could be used in all the different grade levels. And I'll tell you, I go out and I talk to a lot of younger grades. When I talk about things like autonomous vehicles, I'm sure you all have seen this. I get the same questions from a third grade class, well, maybe a fifth grade class that I do as a high school class.
Or adults yesterday.
Yeah, adults yesterday. So they're asking the same questions. Those younger grades, they understand these things. They don't know all the math behind it. They don't know all the chemistry behind it. But they understand kind of what's going on. And it's a great introduction to get them thinking about these things at the younger grades.
So there's not only grade level differentiation, but content area differentiation. In this example, some other tie-ins might be 100-year flood level for the river, average rainfall volumes, cloud physics even, how much water is going to be put down in a specific. Cloud physics is a thing. I just learned about this. That's an actual area of study. People do cloud physics, specifically just that. Blew my mind.
No idea. So up on the screen, I've got, there's a lot of high-tech filter examples that students can build easily. A ton of these on the internet, and you could kind of just pick one, and students are going to learn what a filter is, what different size molecules are, what it means for that water to pass through these different aggregate type of filters. But a better, more costly solution is to use something like a veneer data collector. If you've seen the veneer data collectors, they can collect things from wind speed to the turbidity, the cloudiness in water. The data collectors give you, well, a lot of data, and then you've got a lot of graphs from those data to automatically generate. These are great introductions to graphing data, analyzing large amounts of data, and just simply the method and process of collecting data. Obviously, that ties into science and engineering and technology. That technology component here is usually something the core content teachers aren't really comfortable with, that data collecting technology, but it's pretty simple. Once they use it, they can get on board pretty quick. And obviously the barrier there is cost. I mean, you have to buy the data collector, or we have some here at the ISD.
I've got a story too about this. I'm up, I guess.
Okay.
So in this case, this was I'm going to show another video here, but just to kind of preface it, we might go a little bit past 8:45, but we're very near the end of our presentation here. So what you're going to see here is kind of a video that Rick and I put together around that we. God, I'm stumbling here. Case study. Okay, went out to a school. They were working with light reflection and absorption. I think this was a freshman high school group, and I'm going to play the video here. And whoop, one more over. There we go. All right, so let me come back to this. So those students were working on light reflection and absorption. There's a couple of things. I did see the note. Yes, it was chilly. We actually got some ice on the rotors, and the students had a vernier data collector that we mounted to the bottom of that drone, and we did adiabatic lapse rate. So they collected their own adiabatic lapse rate data. If you don't know what that is, or some of you guys probably do. I'm talking to a bunch of nerds. You guys are my people. So I'm not going to read everything you're seeing on the screen right now, but this is the lesson that we put together for those folks. The students also, you saw how we kind of zoomed in on some of those pictures. They had developed their own lens covers, their own lens filters, I should say, to filter out different wavelengths of light. And their hypothesis was, hey, if we filter this wavelength of light, we should see different temperature, quote unquote, remote sensing science, right? We should see different temperature coming through. And then they were taking their own ground measurements, and we correlated the two data sets. So in this case, we talked then also a little bit about, on the left side there, you can see how we programmed the drone, for flight back and forth over some of their areas. We were able to capture the paved area, some of the soil area, and then the grassy areas in the infield, obviously baseball fields behind the high school. Got permission, piece of cake, no big deal. So when we talk about whether it's a 3D printer or a drone or vernier data collectors, we get this technology in ed tech, and now what do we do with it? Our pitch to you guys is connect it to a business or an industry problem. So in this case, they were examining how much of that energy is going down, and now we're going to try and develop the location for, or the optimal angle for a, what am I trying to say, photovoltaic cells. What's the normal word for that, Rick? Solar cells, there we go, solar's my word. So then on the right side, you can see how you kind of analyze some of the health of a plant, and we had the students looking at that as well and taking that information into account. These are just some of the pictures. You can see where we had the vernier probe located underneath the drone. The little bag, this guy in the middle, by the way, this teacher that was working with me on this, that's Mr. Steve Vertstis of Comstock Park Public Schools. Absolutely incredible, vastly engaging science teacher. The man did an amazing job with his kids. So he had a woolite. Y'all know what woolite is? If I talk about underwear, Rick will yell at me later about it. So, but that little laundry bag that you put stuff in, that's what we attached that thing with. And I did a unit using a drone with kindergartners. They had to figure out, okay, how it doesn't have a carriage device you can see there underneath it. It doesn't have the ability to carry anything. So they were figuring out, how do I attach something to it? And then they had to figure out, okay, how many, I think in kindergarten they have to count up to 20. So the teacher gave them like 30 blocks. Their little carriage thing had to hold 10 of them. And the students had to tell me, okay, these 10, that'll be one trip. And I had to fly them back and forth across the gym. So how many trips to use this flying device to move your blocks? And they had to be able to, do the counting and the grouping for their numbers. So I don't care if it's kindergartners or high schoolers using this technology for an industry type problem. The kindergartner's industry problem was, how many boxes can I move on my airplane? Like if I used to work at FedEx. If I'm a FedEx airline pilot and I got to move all of these boxes, how many boxes, how many airplanes, and solving that type of a problem.
Nope, that's it.
Oh, we're through.
Yeah, that was just kind of, that's Ruby. I bring out the schools, but that is all we wanted to cover today, and we're kind of within our time lot.
We're pretty close. I'm going to bring up, I think down here at the end we had
right.
This is stuff we had intended to skip. Something went sideways in our upload here, but this is how you guys can stay in touch with us. We'd love to work with anybody that is willing to work with us or has some more questions. And that's our time.
Thank you.
And
you guys
Andrew's
are
coming
awesome.
over, so he's going to... Oh, okay. Go ahead and hit mute.
Wow, that was a fantastic presentation. Thank you so much.
Yeah.
So I'm just going to quickly share my screen back to the agenda, just so that we can go over. No, I shared the wrong screen. Got two monitors here. 1 second, folks. So we've got about 10 minutes, 11 minutes before the next set of sessions. If you're attending anyone else hear the echoes, click on the link to Room 1. If you're attending Models for Technology Integration, SAMR and beyond, click on link Room 2. And if you are joining me for Win, Lose, or Draw and talking about Google Drawings in the classroom, you can click on link Room number 3. So we have a great group. There's quite a few of us here today, so this should be a nice dynamic set of sessions this morning. Thanks for everyone who is attending. And we will see you in your various rooms in about 10 minutes. And Kelly, you can turn off the recording for this session. Thanks so much. So Kelly, are you going to leave this room open for a little bit, or are you going to close this one down?
I think I had it set to close down at 9:30.
Okay.
But maybe I'll.
I have to exit out of it to go into the
There it
next
is.
one, huh?
Yeah.